Okay, Jasper has 3 coins. In an experiment, he flips 3 of the coins and records the total number of heads he gets. Jasper believes that the coin is biased. The number of heads he gets can be modeled by the distribution B brackets 3, 0.4. So that the probability of 0 heads is 0.625. Now, what we need to do is need to think about how does a binomial distribution work. And I always like drawing Pascal's triangle. Yeah, and this is fairly easy to work out because all you're doing is adding the ones above it. Now, most of the time you are given this, so I'm surprised this one you're not. Again, now because we've got 3 coins, you've got to think you've got 4 outcomes. And if you look a little bit further down onto part C, you can see the 4 outcomes. So we're going to be doing this one here. And I actually like just listing out all the outcomes too. So I know that P, if I think P's probability of the event is happening, which is 0.4, yeah, which is there. I can know that Q is going to be 0.6. And then we just got to remember the distribution. So I know that P to the power 0, yeah, and it's going to be P to the power 1, P to the power 2, P to the power 3. Right, Q works the other way around. So 3, 2, 1, 0. And then the reason why I put this box in is because that's going to be your coefficient. So 1, 3, 3, 1. And if you remember this expansion, each one represents an event. And I like to look at the P's because I know that P cubed is going to be that event happening 3 times. This one here is going to be 3 heads. That one there is going to be 2 heads. That one there is going to be 1 head. And that one there is going to be no heads. Okay, now let's actually just focus on the question. So there's a probability of no heads. Okay, so I'm using this one here. So it's going to be 1 times P to the power 4 no times, yeah, times 0 to the power 6 3 times. Okay. Now this does simplify down to 0.6 cubed. If you just did that. Okay, and I've got 0.216. I'm going to write it here just because it'll help me out later. The answer here is 0.216. Okay, so change colours. Work out the probability the experiment has exactly 1 head. Okay, so exactly 1 head is going to be this one here. Okay, which is 3 times 0.4 to the power 1 times 0.6 squared. And you essentially just type that into your calculator. And I've got 0.432. 0.432. I'm going to write this down for 1 head. Okay. He carries out the experiment 100 times. The table shows information about the number of heads he gets from the experiment. Determine whether or not the model of B3, 0.4 is suitable for Jasper's experiment. Now I've worked out the probability for the next 2. Yeah. So whether you need to or not, I'm going to do it anyway. Let's do it for the next one as well. So if I'm doing it for 2 heads, it's going to be 3 times 0.4 squared times 0.6 to the power 1. 3 times 0.4 squared times 0.6, which gives me 0.288. And my last one, I'm just going to do P cubed, but when that's space, I'm really going to do it. So it's 0.4 cubed, which is 0.064. Now that's the probability of each event. If we're doing it 100 times, we're just timesing it by 100. So I'd expect my first one it to happen 21 times. My second one I expect to happen 43 times. My next one happens 29 times. My last one I think will happen 6 times. Now if you look at like what we expect to happen and what actually happens, it's not exact, but it's sort of like there. It's roughly about the same. So I'd say, yeah, I'd show my working out, and I'd say that I think this is a good model because our predictions are roughly, yeah, what he actually found in this experiment.